All right, in this lesson, I'm going to teach you how to apply a vertical stretch on a given graph. So on the left-hand side here, we're given the graph of some sort of cubic function, and we're going to sketch the graph of the transform function y is equal to 1/4 of f of x. So when you're taking a look at y is equal to 1/4 of f of x, since we're doing a vertical stretch here, first thing you want to do is determine what that vertical stretch factor is. And to do that, you can always compare to the general form of a function being vertically stretched. And remember, that was y was equal to a times f of x. Now that a value determined what happened to the shape of the graph. So if we're taking a look at these two functions and comparing them, let's determine that a value. So remember, that a value comes outside of the function. So in my transform function, that 1/4 represents the vertical stretch factor. So we'll write it down. Vertical stretch factor by a factor of 1/4. Okay. All right, so since we identified the vertical stretch factor, let's go ahead and apply that vertical stretch on some points. So let's pick some points on the graph here. I'm going to pick -2, -8. Okay. Let's pick -1, -1. So right there. And 0, 0. 1, 1, so right there. And finally, let's pick 2, 8. So I picked 5 good points to help me sketch this transform function. So we picked some points on the original graph, and now we're going to apply the vertical stretch factor. So when you're applying a vertical stretch, remember, for any point on the original graph, x, y, it becomes x comma a times y. Okay, so that was from my previous lesson. So we already determined what that a value is, and that a value was equal to 1/2. So you're applying a vertical stretch factor on all your y coordinates by a factor of 1/4. So all your x coordinates will stay the same, okay? But all your all your y values are going to be multiplied by 1/4. So let's show that. I have -2, -8 times 1/4. Okay, and then next I have -1, -1 times 1/4. Okay, 0, 0 times 1, 1/4. There you go. And here we go, almost there. 1, 1 times 1/4. And finally, 2, 8 becomes 2, 8 times 1/4. Okay, so obviously that doesn't look very pretty. You can't really tell what the points are, so let's carry out some multiplication here. -2, -8 times 1/4 gives you -2. All right, so -1 -1 times 1/4 gives you, if you like decimals when you're graphing, that would be -0.25. Let's keep going here. 0, 0 times anything gives you 0. Okay, 1, 1 times 1/4 gives you 0.25. And 2, 8 times 1/4 gives you +2. So there are the new transform points in blue. And so from here, we simply graph those points and connect them. Okay, so starting with the first one, -2, -2 is right there. Okay, -1, -0.25 is right here. Okay, so I'll try my best there. Then we have 0, 0. Okay, so that point did not change. 1, 0.25, so right there. And finally 2, 2, which is right there. So it still is a cubic function, but when you connect the dots here, what happened is your graph looks now a little wider. So there is the transform graph, and that's how you apply vertical stretch on a given graph.